Welcome everyone. It's great to be here. Actually, when I retired from the Queensland government, I said to people I wanted to do something different, and I think this project certainly meets that brief. I never thought I'd be working on food recycling, but it's been incredibly interesting. We've heard the word biosecurity a lot today, so I thought we might start off with a definition of what biosecurity actually is for those who may not be quite sure what biosecurity is. It's a term that only really started to be used back in the 1990s. So it's basically about managing risk, and risk to do with pests and diseases, and in terms of those pests and diseases entering the country, emerging, establishing and spreading. So it's about controlling pests and diseases. But the aspect of this definition I'd point out is that it's now recognised that biosecurity has an economic impact, it's got a social impact and environmental impact, which fits in perfectly with this project. So I think that's an important part of that definition. And the impacts of biosecurity can be huge. This is an fairly old slide, but if you think back to the SARS outbreak and the foot and mouth disease outbreaks in Great Britain, they have huge economic impacts. And the modelling's been done here in Australia. If we had a foot and mouth disease outbreak in Australia, they talk in figures of around $50 billion impact on our economy, largely because as soon as you get a foot and mouth disease outbreak, all your exports stop dead overnight. So huge impact, and the risks of the biosecurity risks are increasing significantly for Australia. So we've got global diseases spreading. That's African swine fever, which we'll talk a bit more about later. But we've got close proximity to our northern neighbours. We've now got ASF, African swine fever, in Indonesia. Our commodity imports are going through the roof. There's been projections on that, and then by 2030 they're going to be sort of an order of magnitude higher than they are now. International travel increasing. We've heard in the media just recently about the amount of pork products that are being seized at the border, huge amounts, and the latest figures are 50% of them were positive for African swine fever when they test them. And we've got various things. We've got new and emerging diseases, changing demographics, and new and emerging industries, and these all create new risks, new biosecurity risks. If someone starts up a new industry, then people haven't thought through the biosecurity risks, so you can increase your risk through that. Now, just thought it's worth spending a little bit of time on how biosecurity is managed in Australia, because it is a little bit complex. It starts with our constitution, in that basically the constitution the only thing it mentions in terms of biosecurity is the single word quarantine, and it says the Commonwealth's responsible for that. So the Commonwealth looks after the border issues, but basically the way the Constitution's interpreted, everything that's not mentioned falls to the states. So we largely, in biosecurity, in some ways we act like 7 separate countries, because most of the responsibility lies with the state governments, not nationally, even though we're dealing with national industries. So the Commonwealth looks after the border issues, the states and territories look after the post-border issues. That's biosecurity out on the ground. And to actually make that all work together in a national sense, we have these lots of national committees set up to try and coordinate it all, and that works sort of reasonably well. We have our hiccups in it, but the important, in terms of this particular issue we're talking about, Animal Health Committee is probably the most important committee, and that's all the chief veterinary officers of all the states and the Commonwealth. We've got Kevin DeWitt here, who's the current chair of Animal Health Committee, and we've got Alison Crook, CVO Queensland. Kevin's chief veterinary officer of Tasmania, Alison's chief veterinary officer Queensland, and that's a very important committee in terms of setting animal health policy in Australia. And what we've tried to actually engender, because we've got this funny system of the states being largely responsible but a national system, we've got this concept of shared responsibility now that we talk about. So industry's got a role, state governments have got a role, the Commonwealth's got a role, and the community's got a role. So we try and engender that philosophy in everything we do. And I think largely because we have got a fairly complex system in Australia, we actually do this better than most other countries. A lot of other countries, animal health is very much a government-driven thing, whereas in Australia, it's very much a partnership thing between industry and government. So we do that pretty well, and I think, again, this project is a good example of that. And just an example of that shared responsibility, we've got, if we actually get an exotic disease outbreak in Australia, we've got a thing called the Emergency Animal Disease Response Agreement, which is a national agreement between the Commonwealth Government, the state governments, and all the peak industry bodies, so all the, the poultry industry, the cattle industry, all that sort of stuff. They've all signed up to this, and if we have an outbreak, they all share the costs. And an important part of that agreement is that all signatories have an obligation to reduce risk. So before you actually have an outbreak, all the industries have an obligation to do stuff to reduce the risk of actually having an outbreak in the first place. So that's why it's important that we get on top of biosecurity. The other part of it is, I mentioned the states and territories are largely responsible for biosecurity on the ground, so the legislation's all different in each of the states. So there's lots of legislation that applies to biosecurity across the country. Now, why is all this important for food recycling? We'll get down to the nitty gritty. So if you look at that photo, there's can we see any meat in there? But anyway, we'll just have to assume that there's meat in there, and meat can carry diseases. So we've got to ensure that we manage the risks that are carried by actually having meat products in the product. I'll talk a bit more about that a little bit later in terms of what that means. But in looking at this project, in terms of my role is to advise Norm and the team how to make sure we manage these biosecurity risks properly. I've had to look at it from like a worst case scenario, so we've had to assume that any meat in that product could, most of it will be Australian origin, but we've got to assume that some of it could be overseas origin, either legally or illegally imported. So in terms of the treatments and stuff that we apply, we sort of assume the worst case scenario. So if we're talking about feeding this stuff to poultry, what are the major diseases? I was pretty lucky really in that the Commonwealth Government, the Department of Agriculture in 2008 did what's called an import risk analysis for importation of poultry product into Australia. And they looked at all the major diseases and which ones were the highest risk and what treatments would be required. So these sort of the top ones that came out of that. In your your written information booklet, there's I won't go into the detail of what these diseases are, but there's a brief description of each one in those booklets. But probably the two most important in terms of risk coming in with meat would be very virulent infectious bursal disease and salmonella. They're probably the more important ones. The other two, AI and Newcastle disease, probably less likely to come through that mechanism. But how do we actually reduce the risk? So very lucky in the import risk analysis, analysed all the literature and came up with these sorts of figures for the heat time treatments that you need to apply to inactivate those viruses. And basically it comes down to IBD, infectious bursal disease, is the hard one to kill. So it needs a minimum of 80 degrees for at least 125 minutes or equivalent to kill it. The others are less than that. So if we just basically apply the process that would kill IBD, we've sort of taken care of everything else. And there's a few other sort of variations on the right there that would also be killed by that process. And that where it says or equivalent time temperature, they came up with a table. So we can vary the temperature, but if you vary the temperature, you have to vary the time. There's another aspect to this, and it's called swill feeding. And there's a national definition of what's called swill, which is basically any material of mammalian origin, so meat, or any substance that has come in contact with this material. So even if it's veggies that's had meat in contact with it, it's swill. And basically restaurant waste is swill, because we've got to assume there's meat in it. But there's an exception there, so that it's swill unless it's treated by an approved process. So that's what we're aiming for here, is an approved process so that it actually gets treated, so it's not regarded as swill. Now, why is that important? We've got swill feeding regulations throughout the country, and all the states' legislation there's a national agreement on swill. That definition I put up was the national definition. The definition actually varies a little bit from state to state, but basically that's the national definition. So every state has a regulation about feeding swill. So in terms of pigs, you can't feed swill to pigs in any state. It's just illegal. But when it comes to chooks, it's a little bit more complex. So it's illegal to feed swill to poultry in Queensland and South Australia, and I've got a tick and a cross against New South Wales, which I'll explain in a moment, which is a little bit more complex. And I'll explain that now. We're now getting a new generation of biosecurity legislation in Australia, and the first state to bring it in was Queensland, and then New South Wales, and there's also National Department of Ag has brought in a new Biosecurity Act. They're called Biosecurity Acts. And a concept that's starting to take hold in these new legislation, I think we'll see this type of legislation sort of get rolled out in other states over time. But in the Queensland one, they've got what's called the General Biosecurity Obligation, and in New South Wales they call it the General Biosecurity Duty. They're a similar concept. Basically it means that everyone's got a duty or an obligation to ensure that the biosecurity risk is managed in a general sort of sense. And talking to my New South Wales counterparts, they've noted that even though we're producing food to be fed to chickens, the food, if another food producing animal species may inadvertently have access to the food, so if someone accidentally or deliberately feeds this food to pigs, then that creates a potential for access of pigs to, they can't be ruled out. And so their regulation in relation to swill feeding must be complied with. So basically, even though it's not specifically illegal to feed swill to poultry in New South Wales, the interpretation of this general biosecurity duty is if pigs could inadvertently be fed this food, well then it should meet the swill feeding regulation. So in effect, basically, we need to ensure that it's even when fed to poultry, it meets the swill feeding regulation. So that means we've got to be concerned about pig diseases also. So the two major ones for pigs are foot and mouth disease, which has always been the big bogey disease for Australia. As I mentioned before, a significant outbreak could cost us $50 billion. But the current one that we're worried about is African swine fever, because it's been spreading all through Asia and Europe over the last year or so, and it's now not very far away, and a lot of the product being imported into Australia illegally is infected with it. Latest results I saw, 50% of product tested has been positive for ASF. So what do we need to do? Oh, that's just another slide just saying that there's huge numbers of pigs being wiped out over the world. This foot and mouth disease is not a disease that actually kills many animals. It infects pigs and cattle and sheep, etc. It causes huge production loss, and it's incredibly infectious and spreads like wildfire. African swine fever actually kills pigs, and depending on the strain can kill up to 100% of pigs, so it's a really deadly disease. So how do we inactivate that? So the current Australian standard for cooking a swill says 70 degrees for 30 minutes, which is probably, I'm not quite sure, but it's probably based on the foot and mouth disease standard, but that's currently under review nationally, and it's likely there's an international standard that says you have to cook it for 90 degrees for 60 minutes with stirring, or an equivalent like 120 degrees for 10 minutes, that sort of thing. But that Animal Health Committee that I mentioned earlier is currently reviewing this, and they may come up with a slightly different figure. They haven't actually come to a landing point on that yet, but it could be something like 100 degrees for 30 minutes or something like that. But anyway, we'll just need to wait to know what the final figure is that we need to treat this stuff at. But we're confident that with the process we can meet whatever standard is sort of finally decided upon. Now, the other part of biosecurity that I mentioned is contaminants. So we're collecting basically waste from all over the place. So it could have agricultural veterinary chemicals in it, could have natural toxins from plants, could have metals and various things in it, could have carcinogens from burnt food or packaging, and it could have mycotoxins from fungi. So we do need to think about that as well. And you might have, I suppose your initial thought might be, well, this is food that's been produced for human consumption, shouldn't be a problem. Pesticides shouldn't be a problem, but that's actually, you can't assume that, because for a start, a product that's used on one product may not be registered for use on another product. So the best example I can give you of that is a number of years ago during one of the droughts like we've got here, people started feeding cotton waste to cattle as a drought feed. And that cotton had been legally treated with CFZ, I can never say it properly, chlorfluorazuron, which is a chemical used on cotton. That was perfectly legal, but it was never registered for use on cattle. So the cattle ended up with these residues of CFZ in them, and that actually threatened the whole export market of beef to the US. So we nearly lost that export market. So you can't assume anything. Also, maybe imported foods may not meet our Australian standards. You can have spoilage of food from fungi, and producing mycotoxins such as aflatoxins, and that's one reason why we're collecting the food daily, so that there's minimise the chances of that building up. And you can have biogenic amines from microbial spoilage as well. So what are we going to do about that? Firstly, we think that the dilution, the fact that we're putting a whole heap of different products together and mixing them up, there'll be a dilution factor. If there's a chemical in one component, that'll dilute it out. Heat degradation will also occur with some chemicals. It'll break some down. But unfortunately, at this stage, we've got insufficient data really to know what the profile is, and we can't really design a monitoring program at the moment. So what I've been doing, I've been talking to a scientist called Stephen Weir. He's in the chemical residues lab in Brisbane, and we're very shortly going to start using a technique he calls extensive chemical residue screening, where we test for a whole range of chemicals. So we're going to do, of this product that's been produced now, we're going to test a heap of that, and that'll then we'll use that data then to design a future ongoing monitoring program that will be required for this process. So bring all this together. I've produced a biosecurity protocol, or a draft one, that it'll probably get modified over time. But what's in that is, so for IBD we need to ensure a minimum of 80 degrees for 125 minutes during the process, but no less than 75 degrees. And then 90 degrees for at least 60 minutes, or whatever we come up with as a national standard. They can be run in sort of parallel. And this table on the right is probably a little bit out of date now. Brendan supplied that to me. This just gives you an idea of some of the temperatures in the different phases, but at the moment they're actually running at 140 degrees for 2 hours, so that blows everything out of the water. So
that's the in-feed gas, not necessarily the temperature of the product.
So I suppose basically what the important message is that we can adjust the temperatures to meet whatever the biosecurity requirement is. So we're reasonably confident we can meet that. But there's some other things we need to do as well. So I've mentioned the collecting food waste daily, so that it reduces that build-up of biogenic amines and mycotoxins. I should have mentioned that any of this material with meat in it can't be fed to ruminants, so it has to be labelled that way. It's illegal because of, you would have heard of mad cow disease, bovine spongiform encephalopathy. Well, it's basically illegal to feed any what they call restricted animal matter to ruminants, and it has to be labelled that way. We can design a residue monitoring program, and normal things such as putting date, place of production, etc. on the bag, maintaining good production records, and retaining samples for for testing if that's required. And we're also looking at accreditation under the Feed Safe program as well. So that's basically, in summary, what we're going to be doing to manage the biosecurity aspect of this process.